Let's try to solve another hydrodynamics problem. So sabi dito, a jet of water moving at 45 meters per second impinges without shock a series of vanes moving at a velocity of 15 meters per second. The direction of motion of vanes is inclined at 20 degrees to that of the jet. The relative velocity at outlet is 0.9 to that of inlet, and the absolute velocity of water at exit is to be normal to the motion of vanes. Find A. Vane angles at entry and exit. B. Work done on vanes per unit weight of water supplied by the jet. And C is hydraulic efficiency. So here is our illustration for this specific problem. So let's try to supply the given values to our illustration. So first, makikita natin 45 meters per second. So that is our V1. So V1 is located here. This is your V1, which is 45 meters per second. And then the vanes that are moving 15 meters per second. So yung movement na yan is along the x-axis. So nandito yan siya. V prime is equal to 15 meters per second. So V prime is the movement of our vanes. So since wala naman siyang ibang binigay na velocity, we will assume na yung V prime sa point 2 is also equal to V prime at point 1. This is point 1 and this is point 2. So the V prime here, which is this line, is also 15 meters per second. The direction of motion of vanes is inclined at 20 degrees to that of the jet. So ito yung tinutukoy niyang angle. So this angle is equal to 20 degrees. The relative velocity at outlet is 0.9 to that of inlet. So the relative velocity at point 1 is here. So this is our U1. And then our U2 at point 2 is here, directed towards the upper left. So this is our U2. And the absolute velocity of water at exit. So the absolute velocity of water at exit, so at point 2, is to be normal to the motion of vanes. So ibig sabihin, nandito rin siya parallel along the U2. Hindi na tayo kailangan maglagay ng separate na line for the velocity at point 2. So nandito na yun siya parallel sa relative velocity at point 2. So now solve agad natin yung ating V1x. So V1x is equal to V1 cosine 20 degrees. So that is 45 meters per second cosine 20 degrees. That is 42.29 meters per second. No, nakalimutan ko. So this velocity is our V1 normal, which is also equal to our U1y, and this velocity is our U1x. So x component na ang ating relative velocity. And for point 2, this is our V2 normal, which is also equal to, since ito ay relative velocity at point 2 and it is directed towards the upper left, so this is our U2y component. So now to solve for V1n, that is also equal to V1 sine 20 degrees. So that is 45 meters per second sine 20 degrees. That is equal to 15.39 meters per second. Now to solve for U1x, U1x is the difference ng ating V1x. So ito yung ating V1x, yung total sum ng ating V prime and U1x. So that is V1x minus yung ating v prime para makuha natin itong x component ng ating relative velocity at point 1. That is v prime. So v1x is equal to 42.29 meters per second minus the v prime, which is 15 meters per second. Now that is equal to 27.29 meters per second. Now to solve for the vane angle at entry, we need to use the tangent function. So using the tangent function, we can solve for theta u1. So ito yung angle na yun. This is theta u1. Theta u1 is equal to tangent negative 1 v1n opposite over adjacent, which is u1x. So that is equal to tangent negative 1. Value for v1n is 15.39 meters per second over u1x, which is 27.29 meters per second. So mag-cancel meter per second. Now this is equal to 29.42 degrees. So now in order na ma-determine natin yung value ng ating U2, which is 0.9 to that of the inlet. So U2, meaning to say, is 0.9 of U1. So it is necessary for us to find the value for U1 in order to solve for the value of U2. So to solve for the value of U1, we need to use the sine function and the values for our v1n and our theta u1. So that is v1n over sine theta u1. So kapag ni-rearrange natin yung equation natin na ito, so that is sine theta u1 is equal to opposite. Opposite niya ay yung v1n over the hypotenuse. Yung hypotenuse natin is u1n. Pero since ang hinanap natin ay u1n, ganito ang ating arrangement ng equation. So v1n is equal to 15.39 meters per second over sine theta u1, which is 29.42 degrees. Now that is equal to 31.33 meters per second. Now we may be able to get the value for our u2. So u2 is equal to 0.9 times the value of u1, which is 31.33 meters per second. u2 therefore is 28.2 meters per second. Now in order to solve the value for our vane angle at exit, so that is this angle, and this angle is theta u2. So to solve for theta u2, we need to use the value of our u2 and the value of our v prime. So using the cosine function, cosine theta u2, the adjacent of our angle is 15 meters per second, so that is v prime, over the hypotenuse, which is u2. So now to solve for theta u2 is equal to cosine negative 1 v prime over u2. That is cosine negative 1. The value of our v prime is 15 meters per second over value of u2 is 28.2 meters per second. Cancel. Now that is equal to 57.87 degrees. So this is now the value of our vane angle at exit. Now to solve for the value of our work is equal to force along x, then our v prime. The force along x, that is rho v v1x minus v2x, that is our force, multiplied to v prime. And since ang binigay sa atin ay mass flow rate, we know na ang mass flow rate is equal to density times volume flow rate. where mass flow rate is equal to density times volume flow rate. From the formula of density, where density is equal to mass over volume. So density times volume is equal to the mass. So we can write this equation as mass flow rate V1x minus V2x times our V prime. But since dito sa ating illustration ay wala tayong value for V2x, so meron lang tayong V prime, relative velocity at point 2 and V2n, so our V2x actually is 0. So to solve for our work, that is now equal to mass flow rate times V1x times our V prime. So this is equal to, assuming na ang mass flow rate natin ay 1 kg per second, assume natin na ang mass flow rate ay 1 kg per second. So to solve for work, mass flow rate na 1 kg per second times V1x. So value ng V1x is 42.29 meters per second times the value of V prime, which is 15 meters per second. Now that is equal to 634.35 watts. So paano naging watts? So that is kilogram per second times meter per second times meter per second. So kilogram meter per second squared, pag pinag-multiply natin to, this is Newton. Newton times meter per second. And Newton meter per second is equal to joule per second, and joule per second is equal to watts. So that's why naging watts na yung ating unit for work. So this is now the value of our work, 634.35 watts. And to compute for the efficiency, that is work over KE in, that is work over 1/2 mass flow rate V1 squared. That is 634.35 watts over 1/2 mass flow rate, assuming na 1 kilogram per second, and V1 na 45 meters per second quantity squared. Now this is equal to 0.6265, and kapag minultiply natin siya sa 100, this will result to 62.65%. Now this is the efficiency for this problem. So these are now the solutions for this problem. So nakuha natin yung vane angle at entry, vane angle at exit, the work done, and the efficiency. So now shout out sa mga mechanical engineering students ng Palawan State University, specifically sa Block A and Block B na third year mechanical engineering students. Shout out din specifically kay Patrick Aranchado, shout out kay Jasper Lumanas, shout out kay Eric Dicano, shout out din kay Marvin Doroteo and kay Troy Manalo, shout out kay Vincent ng Block 3A, shout out sa mga kaklase ko rin sa Block 3B, si Manong Jefte and si Arik Balahadja. So that's it for this problem. Thank you.